All3 has just secured $25 million in seed funding to scale their AI-powered construction robotics. This is not a vague promise of future technology. The real stakes involve the physical impossibility of building a house without human hands, a problem that has stalled the entire industry for decades. By the end of this analysis, you will understand exactly why this capital injection matters, not because of the money, but because of the specific engineering pivot from rigid automation to adaptive simulation that defines the new era of physical AI. The construction robotics sector has spent the last decade chasing a ghost. The dream was always to build a machine that could lay bricks with the speed of an industrial arm and the dexterity of a human mason. The reality has been a graveyard of expensive prototypes that work in a controlled lab but fail the moment a single brick is slightly out of alignment. This failure is not due to a lack of hardware. It is due to a fundamental misunderstanding of how physical systems interact with chaotic environments. Every robotic arm that has failed on a construction site has failed because it was programmed for a perfect world that does not exist. All3's new funding signals a strategic pivot away from purely hardware-centric automation. The industry is finally realizing that the value driver is no longer the mechanical gripper or the hydraulic lift. The value driver is the software that simulates the physical world with such high fidelity that the robot can predict failure before it happens. This shift validates the emerging simulation to reality paradigm. In the past, engineers would program a robot to perform a task and then hope it worked in the real world. If the brick was off by 2 millimeters, the robot would either jam or drop the load. Now, the software creates a digital twin that accounts for every variable, from wind resistance to material deformation. This approach relies on a technology stack that treats simulation as the primary interface for the robot. Think of it as a flight simulator for a bricklaying machine. The robot does not learn by making mistakes on a real wall. It learns by simulating millions of variations in a virtual environment where failure is free. This is where the concept of generative AI becomes critical. The system does not just follow a pre-written script. It uses large language models to interpret complex construction sequences and then generates the specific motor commands required to execute them. This allows the robot to adapt to a wall that is not perfectly square or a foundation that is shifted during the night. Quick resource note: I keep a curated set of Amazon search links in the description for books, gear, and tools relevant to this channel's topics. Some are affiliate links, so I may earn a commission at no extra cost to you. Please consider supporting the channel by using those links if you find something useful. The engineering challenge here is immense. You are trying to translate a digital model into a physical object using discrete robotic assembly. The constraints are brutal. Sustainability requires that the robot minimizes waste. Functionality demands that the structure holds up under load. But the biggest constraint is time. Construction sites are dynamic. The environment changes every hour. A robot that takes 10 seconds to plan its next move is useless on a site where a human can lay a brick in 3 seconds. The All3 system must bridge the gap between the slow, deliberate nature of AI planning and the rapid pace of physical construction. To achieve this, the system likely leverages open-source frameworks and simulation tools to de-risk the high cost of physical prototyping. In the past, every new robot design required a physical prototype that cost hundreds of thousands of dollars and months of development time. With advanced simulation, the robot can be tested in a virtual environment where it can fail 1,000 times in the time it takes to build a single physical unit. This allows engineers to iterate on the control algorithms at a speed that was previously impossible. The result is a system that is not just automated, but adaptive. It can handle the unpredictability of a real construction site without needing a human to intervene. This convergence of generative AI models and robotic hardware suggests a future where construction workflows are dynamically optimized by software agents rather than pre-programmed rigid scripts. The robot is no longer a tool that executes a fixed set of instructions. It is a partner that can reason about the task at hand. If a brick is damaged, the robot can identify it, select a replacement, and adjust its grip strategy in real time. This level of autonomy is what investors are betting on. They are not buying a machine. They are buying a capability that scales. The capital raise highlights a growing investor confidence in physical AI startups that leverage these simulation tools to solve the hardest problems in construction. The industry has been waiting for a solution that does not require a complete overhaul of the construction process. All3's approach offers a way to integrate robotics into existing workflows without disrupting the entire supply chain. The robot works alongside human crews, handling the repetitive and dangerous tasks while humans focus on the complex decision-making. This hybrid model is the only one that makes economic sense at scale. The most valuable insight here is that the hardware is becoming a commodity. The real differentiator is the software stack that allows the robot to understand the physical world. The ability to translate a digital model into a physical object is no longer a theoretical concept. It is an engineering reality that is being deployed today. The simulation to reality gap is closing because the simulation is becoming more accurate than the real world. This is the turning point. It is the moment when the digital twin becomes more reliable than the physical prototype. This shift changes the entire economics of construction robotics. The cost of failure drops dramatically because the robot learns from virtual failures rather than physical ones. The speed of deployment increases because the system can be updated via software rather than hardware modifications. The scalability improves because the same software can be deployed across different sites with different constraints. This is the future of construction. It is not about replacing humans. It is about augmenting human capability with machines that can think, adapt, and learn in real time. The journey from a rigid machine to an adaptive partner is long and difficult. It requires deep expertise in robotics, artificial intelligence, and civil engineering. But the momentum is undeniable. The $25 million raised by All3 is not just fuel for a startup. It is a signal that the industry is ready to embrace a new way of building. The future of construction is not just automated. It is intelligent, adaptive, and deeply integrated with the digital tools that design it. Thanks for watching all the way to the end. I am a one-person team working hard to make each video better than the last. Subscribe if you found value. It is the best way to show support. Drop a comment with your biggest takeaway. See you in the next video.